Hello everyone. Today we're going to discuss all about permeability or flow of water through soils. Soils are permeable due to the existence of interconnected voids through which water can flow from points of high energy to points of low energy. It is necessary for estimating the quantity of underground seepage under various hydraulic conditions, for investigating problems involving the pumping of water for underground construction, and for making stability analysis of earth dams and earth retaining structures that are subject to seepage forces. Permeability is very important in soil mechanics as we know that water is very critical in construction. The concept of permeability started from the Bernoulli's equation. So from fluid mechanics, we know that according to Bernoulli's equation, the total head at a point in water under motion can be given by the sum of the pressure, velocity, and elevation heads, or H is equal to U over unit weight of water plus V squared over 2G plus Z, where H is equal to the total head, U is the pressure, V is the velocity, G is the acceleration due to gravity, and unit weight of water is equal to the gamma sub W. So this U over unit weight of water is called the pressure head. V squared over 2G here is equal to the velocity head, and Z is the elevation head. If Bernoulli's equation is applied to the flow of water through a porous soil medium, the term containing the velocity head can be neglected because the seepage velocity is small and the total head at any point can be adequately represented by just H is equal to the U over unit weight of water plus Z, or the elevation head, because the velocity head was already neglected in the equation. So, in order for us to understand more about the Bernoulli's equation, here is an illustration about 2 points wherein there's a flow of water, and the loss between 2 points A and B can be given by change in H is equal to H sub A minus H sub B. So difference between this water level here and the water level at point B is equal to change in H. And this has elevation HA and HB. That's why difference between HA and HB is equal to the change in H. Or it is also equal to the pressure head at point A plus the elevation head at point A. So this is the elevation head at point A, and this is the pressure head at point A, minus quantity of the pressure head at point B plus the elevation head at point B. So this Bernoulli's equation also introduced the concept of what we call the hydraulic gradient. So hydraulic gradient, or I, is equal to change in H, or the change in elevation of two water levels, all over the length, or the soil length between points A and B. That's why this is the distance between points A and B. That is the length of flow over which the loss of head occurred, because we are getting the change in H between points A and B, and that would be L. So the concept of permeability also started from Darcy's law. So in 1856, Darcy published a simple equation for the discharge velocity of water through saturated soils, which may be expressed as V is equal to Ki, where V is the discharge velocity, which is the quantity of water flowing in unit time through a unit gross cross-sectional area of soil at right angles to the direction of flow. K is what we call the hydraulic conductivity or otherwise known as the coefficient of permeability. And I is what we call the hydraulic gradient or equal to H over L. If the quantity of water flowing through the soil in unit time is Q, then we know that Q is equal to the area times the velocity, or it is also equal to AV Vs, where Vs is equal to the seepage velocity, AV is area of void in the cross-section of the specimen. Therefore, A is equal to AV plus Vs. We know that the total area of soil is equal to the area of voids plus the total area of soil particles or soil solids. If we substitute it in the equation AV, Q equals AV, we substitute the value of A, it will be equal to V multiplied by A, quantity AV plus AS equals AV Vs. So this equation, we substituted the value of A in here. That's why it became like this. And then, if we transpose the values and get the value of Vs or the seepage velocity, it will be equal to velocity or the discharge velocity multiplied by area of the voids plus area of soil solids all over area of voids. And therefore, if we multiply it to the both numerator and denominator by the length of the soil, it will be equal to the volume because area times length is equal to volume, and Vs will therefore be equal to V times the volume of voids plus volume of soil solids all over volume of voids. Therefore, Vs will be equal to, if we multiply the both numerator and the denominator by 1 over Vs, we'll get Vs is equal to V multiplied by Vs over Vs. If we multiply, this will be Vs over Vs and Vv over Vs all over Vv over Vs. And what is Vv over Vs? That is equal to E. And this will be the equation 1 plus E over E. And we know that E over 1 plus E is equal to N. So that's why 1 over N is equal to 1 plus E over E. And therefore, the seepage velocity is equal to the discharge velocity all over the porosity. In permeability, we have what we call the hydraulic conductivity. In order for us to understand more about permeability, we should know more about the hydraulic conductivity, or what we call the coefficient of permeability. So hydraulic conductivity is generally expressed in centimeters per second or meter per second in SI units. Hydraulic conductivity of soils depends on several factors. So number one, it depends on fluid viscosity. Why? So pag mas malapot ang fluid, mas mahirap siyang mag-flow through soils. Also, number two, pore size distribution. So, the larger the pore size, mas madaling mag-flow ang tubig through soils. The smaller the pore sizes of the soil, the slower the water will flow through it. And also, number three, grain size distribution. Why is it a factor that affects the hydraulic conductivity of soils? So, if we compare gravel to clay, and we let water flow through them, so mas mabilis mag-flow ang tubig sa gravel kesa sa clay kasi the larger the grain sizes, the larger also the spaces between its particles. Kaya mas mabilis nagfo-flow ang tubig sa gravel kesa sa clay na sobrang liliit ng particles niya, compacted na yung particles niya na magkakadikit na. So, maliliit na yung spaces in between them. So, mas mabagal mag-flow ang tubig sa clay. Also, we have void ratio. So the higher the void ratio, the higher the flow of water through it. The lower the void ratio, the slower the water will flow through it. And then roughness of particles or roughness of mineral particles. So if the particles are rough, so mas mahirap mag-flow ang tubig kesa sa smooth yung particles natin. Mas mabilis mag-flow yung tubig. And lastly, degree of saturation. So why degree of saturation? So if ang lupa, saturated na siya, mas mabilis na siyang mag-flow ang tubig kesa sa unsaturated soil. In clayey soils, structure plays an important role in conductivity. So other major factors that affect the permeability of clays are the ionic concentration and the thickness of layers of water held to the clay particles. So the value of hydraulic conductivity varies widely for different soils. The hydraulic conductivity of unsaturated soils is lower and increases rapidly with the degree of saturation, as what I have said earlier. And K is equal to the unit weight of water all over and multiplied by K bar rather, where unit weight gamma sub W is equal to the unit weight of water, N is equal to the viscosity of water, and K is the absolute permeability. And that is expressed in L squared or centimeter squared or feet squared, so on and so on. So hydraulic conductivity differs depending on the type of soil. So this is a table representing the typical values of hydraulic conductivity of saturated soils. And depending on the type of soil is the range of hydraulic conductivity or coefficient of permeability. So if the soil type is clean gravel, definitely the coefficient of permeability is higher. So it ranges from 1 to 100 centimeter per second. If it's coarse sand, it's about 0.01 to 1.0 centimeter per second. Fine sand ranges from 0.001 to 0.01 centimeter per second. If it's silty clay, it's about 0.00001 to 0.001 centimeter per second, and if it's clay, it's less than 0.00001 centimeter per second. So in order for us to determine the coefficient of permeability, there are tests in the laboratory. So the number one test in the laboratory is what we call the constant head test. So in this type of laboratory setup, the water supply at the inlet is adjusted in such a way that the difference of head between the inlet and the outlet remains constant during the test period. After a constant flow rate is established, water is collected in a graduated flask for a known duration. So when it comes to constant head, i-maintain natin itong head na ito, head difference between these two. So at a certain time, kukunan natin ng time kung gaano katagal nating na-collect itong volume of water na ito and kailangan maintained yung ating water level difference, and that is H. Yun kaya siya tinawag na constant head test. So constant head test is generally used for coarse grained sand. Coarse grained soils like sand and gravel. The total volume of water collected may be expressed as Q is equal to AVT, so area multiplied by the velocity times time, or we substitute the value of V, or the discharge velocity, as Ki. So where Q is the volume of water collected, A is area of cross-section of the soil specimen, and T is the duration of water collection, as what I have mentioned. So kailangan nating kunin yung time, kung gaano katagal na collect yung total volume of water na kailangan natin. So in constant head test, we have to determine the hydraulic gradient, and we know that hydraulic gradient is equal to H over L, and Q is equal to A times Ki times time, and if we substitute the value of I in the equation, this will be equal to Q equals A multiplied by K H over L times T, and we have to get K from the laboratory test. That's why we need to get the value of K here. So that's why K is equal to Q, the discharge, multiplied by the length of the soil sample, all over A, which is the area, multiplied by H, or the difference between the water levels, multiplied by the time collection of water. So we also have another test, and that is what we call the falling head test. So as I have mentioned, constant head test is used in coarse-grained soil, while falling head test is used in fine-grained soils like silt and clay. So water from a standpipe flows through the soil. The initial head difference H1 plus at time t is equal to 0 is recorded, and water is allowed to flow through the soil specimen such that the final head difference at time t equals t sub 2 is h sub 2. So this is an example of a falling head test. So yung ating, dahil nga fine-grained soil siya, halimbawa silt and clay, matagal mag-flow yung tubig. Kaya ito, yung head difference mula, yung initial head difference, kinukuha. Tapos, after certain time, pag nag-flow na yung tubig, so kukunin natin yung pangalawang head difference. And that will be H sub 2. So, bababa. Kaya siya falling head, hindi i-maintain yung difference ng water level kasi bababa ito. That's why there will be 2 H sub 1 in the final H, or final head. Final difference between the heads or the water level. So, this is the initial difference between the water level. So, the falling head test is equal to, the concept of the falling head test is also equal to Q equals K multiplied by I, Kia, H over L multiplied by the area. But because falling head siya, so hindi constant yung ating ang tawag dyan, yung ating water level, meron tayo, it will be equal to negative A dH or over dt. So we have to apply the concept of calculus here. So where Q is equal to flow rate equals A is area, or cross-sectional area of the standpipe. A is equal to cross-sectional area of the soil specimen. If you are wondering what is the standpipe. So, in falling head test kasi, let's go back first. So, merong standpipe kasi ito. Ito yung length ng lupa. Ito yung area, yung big A, letter A. Ito naman yung area ng standpipe. Ito. So, kadalasan siya ay circular area. Ito ay circular din naman kabilog. Cylindrical kasi ito. So, ito yung letter A na malaki and this will be the letter A na maliit. That's why meron siyang difference dito ng dH over dt. Kasi yun yung we have to apply the concept of calculus here. So, from that equation, dt will be equal to AL, AL over AK multiplied by negative dH over H. So we just transposed the values here. And ito yung lumabas. We rearrange the equations. And by applying integral calculus, dt, the integral from 0 to t is equal to h1 over h2, from h1 to h2, AL over AK multiplied by negative dH over H. And if we consider AL and AK as constant, so this will be constant. So we have to get the integral of this one. This will be negative ln of H. So from H1 to H2. And the integral of dt from 0 to t is t. So that's why t is equal to AL over AK multiplied by negative ln of H sub 2 minus negative ln of H sub 1. And therefore, will be equal to AL over AK multiplied by negative ln of H2 over ln of H sub 1. And therefore, T is equal to AL over AK. So, we apply the logarithmic laws. So, this will be ln of H1 over H2. So, the time we used here is equal to AL over AK ln of H1 over H2. And we already know the time here. That's why if we rearrange the equation and we have to get the permeability, coefficient of permeability or hydraulic conductivity, this will be equal to K is equal to AL over AT ln of H1 over H2. Or if we use logarithmic function, this will be equal to 2.303 AL over AT logarithm of H1 over H2. So empirical correlations for hydraulic conductivity. So there are scientists or soil mechanics enthusiasts na experiment ng hydraulic conductivity and nalaman nila na may mga ranges daw yung may iba't iba silang formula regarding K. Hindi man ang ginamit nila is yung falling head test and yung hydraulic conductivity, constant head test. So, sabi ni Hazen, K is equal to CD10 squared, or D10, we know that D10 is effective diameter. So, the diameter at 10% passing. Sabi naman ni Casagrande, K is equal to 1.4 E squared multiplied by K sub 0.85, or K sub 0.85 is corresponding value at a void ratio of 0.85. Kozenik-Karman is equal to C sub 1 multiplied by E sub 3, E cube over 1 plus E, where E is equal to the void ratio. C sub 1 is constant. And according to Singhe, Wang, and Renvich, for normally consolidated clays, K is equal to C sub 3 E raised to N over 1 plus E, where C and N are constants and E is void ratio of the soil. So to further uh, understand more about permeability, so we have to also know the equivalent hydraulic conductivity in stratified soil. So ang lupa kasi, 'di ba? Hindi naman 'yan pare-pareho sa isang area, hindi man pare-pareho ng types. So, 'di ba, ang soil profile would be like this. Say, for example, this will be a silty sand, uh, clayey silt, silty clay, and then clay. So, if we consider this soil profile, that depending on the type of soil, magkakaiba din yung kanyang hydraulic conductivity or coefficient of permeability. So that's why meron tayong equivalent hydraulic conductivity na inatawag. So say for example, this is a soil profile. At yung direction of flow natin is along dun sa lupa. This will be horizontal. Kukunin natin yung horizontal hydraulic conductivity niya. So, by horizontal, hydraulic conductivity or equivalent hydraulic conductivity is equal to 1 over H multiplied by K1, yung KH nung unang soil, multiplied by yung height niya, plus KH2 multiplied by H2, and then the coefficient of permeability by the third layer multiplied by the height of that layer, and then hanggang sa n layers natin. So, tandaan, pag parallel dun sa lupa at sa direction, that would be horizontal yung ating flow. So, horizontal siya na nakaparallel dun sa direction. So, kahit yan ay nakahiga, halimbawa, nakaganyan, na i-drawing natin, say for example, say for example, this one. Nakaganyan siya. But still, the direction is pa ganun. Sorry for my drawing. This will still be horizontal. You have to get the horizontal, equivalent horizontal hydraulic conductivity kasi along siya dun sa layers ng soil. Kung nagkataon na pa ganyan, so perpendicular, di ba? And iyan, halimbawa, pag ganyan. This will be vertical. Kasi, pag horizontal, sabay-sabay na nadadaanan yung lupa. Pag vertical, layer by layer. Tandaan, class. So, here we have to erase first this. And then, that's why we came up with the vertical. So, by vertical, yan nga, per layer of soil muna yung adaanan ng ating lupa. Nung tubig. So, per layer. Pag sa horizontal, pag ganyan. Halimbawa, pag ganyan siya again, let's draw again. So, pag ganyan siya, ay baliktad. Sorry. Let's erase first. So, pag ganyan siya, ito yung layers ng lupa natin. And the direction of the soil, of the water is pag ganito. So, this will still be vertical kasi per layer yung daan ng ating tubig. So, per layer, that will be equal to the vertical coefficient of hydraulic conductivity. That will be equal to H, so the total height of the soil, all over H1 over the vertical hydraulic conductivity of the first layer plus H2, so the height of the second layer, all over the vertical hydraulic conductivity of the second layer plus HA over KV3 plus HN over KVN. So for N layer of soil, nth layer rather. So we also have what we call well-in and unconfined permeable layer underlined by an impermeable layer or unconfined aquifer natin. So pag unconfined aquifer, so paano nag-work itong test na to? So ito naman yung ating pag-test dito, sa field tayo nagte-test, hindi sa laboratory. So, meron tayong test well na inatawag, na lagyan to ng pipe. Tapos, yung pipe na yun, kinukuhaan niya yung distance ng 2 observation wells. So, meron tayong observation point dito, observation point 1 and observation point 2. So, pag kasi tayo ay halimbawa, ito yung lupa natin. Lagyan natin ng pipe dito. Ang mangyayari dyan, yung tubig natin, di ba mababa? Parang nag-swirl-swirl yan. Kaya nagkakaroon tayo ng natawag na drawdown. So, ito yung drawdown, yung pagbaba ng tubig dito. Dito mababa yan. Pag ganyan, hindi siya. As in, mababa agad ng diretsong babang ganun. So, pag ganyan siya, mababa. Drawdown. So, dito sa first point, mababa pa yung pagkaka-drawdown. So, malaki ng malaki. Hanggang dito sa number 2. So, ito ay yung first drawdown. And then yung second drawdown ay ito. This will be the second drawdown. Ito. First drawdown and second drawdown. So we have to determine, therefore, H1 and H2. So H1 will be the difference between the total height, the initial height, minus the drawdown here. H2 will be equal to the total height minus the drawdown here. That's why in filled K in unconfined aquifer is equal to Q, the discharge ln of R1, so yung distance from the center to the first observation well. Observation point. All over R2. So the distance from the center to the second observation point. All over pi multiplied by h sub 2 squared. So the h sub 2 squared is here. And I'm sorry, that should be h sub 1 squared all over h2 squared here. Mas malaking value dapat nito. All over 2. And well in a confined aquifer underlined by an impermeable stratum. So pag naman, Pag naman confined aquifer, it will be equal to Q ln of R1 over R2 all over 2 pi T times, that should be H1 minus H2. H1 ito, yung mas malaking value minus H2. But still, this will be R1 over R2. So we also have the concept of transmissibility or transmissivity and hydraulic conductivity or permeability. So transmissibility is the ability of an aquifer to transmit water through its entire thickness. It is most simply defined as the effective hydraulic conductivity of an aquifer by the thickness. And T is equal to KH. So to further understand the topic, let us first solve problems regarding the topic. So, sample problem number 1. So for a constant head laboratory permeability test on a fine sand, the following values are given. Length of specimen, L is equal to 10 inches. Diameter of specimen equals 2.5 inches. Head difference is equal to 22 inches. Water collected in 2 minutes is equal to 0.044 inches. Cubic inch rather. So if you look at the problem, it says find sand. So it doesn't mean that it's because it says it's fine, dapat falling head. But it's still sand. It's still coarse grained soil. So that's why we used constant head laboratory permeability test. So the void ratio of the specimen is 0.34. So we have to determine the conductivity K of the soil in inch per minute and the discharge velocity V through the soil in inch per minute and the dissipation velocity or Vs in inch per minute. So how are we going to solve for the problem? So solution, K is equal to QL over AHT. So given is the water collected in 2 minutes is 0.044 inch cubic inch. That's why this will be Q. Multiplied by 10 inches, the length of the specimen is 10. All over the area of the specimen, it has a diameter of 2.5 inches. So this will be pi over 4 multiplied by 2.5 squared. And then we multiply it to 22, the H head difference multiplied by the time, which is 2 minutes. And we get the answer, K will be equal to 2.037 multiplied by 10 raised to negative 3 inch per minute. In letter B, we have to determine the discharge velocity or V. So we know that V is equal to Q over A from the first formula, from the concept of Darcy. So if we substitute here, so discharge, so dapat kasi yung 'di ba Q is equal to AVT. So pag Q here, dapat per inch per cubic inch per time siya. So per minute. So that's why 0.004 all over pi over 4 times 2.5 squared. So this will be equal to, therefore, 4.818 times 10 raised to negative 3 inch per minute. So bakit, if you ask me, bakit dito yung Q is in cubic inch per minute, dito naman ay cubic inch lang. So ito kasi yun. So pwede din dapat yan ay VL over VAHT. So, dapat yan ay V talaga. Yung volume. Volume, not velocity. So, kaso nga lang, introduce ng authors is Q. So, pwede naman kasing Q is discharge in cubic inch or cubic meter, or also pwede din siya na cubic meter per second or cubic inch per minute or per second. So, nakadepende sa given. So, pwede kasing discharge yun. So, in volume over time or just volume. So, para makuha kasi natin yung velocity, Q here should be in volume over time. That's why ito dapat volume to. Dapat pwedeng volume to. Pero yung authors kasi, Q talaga yun or discharge. Kasi V nga is, we denote V here naman is as discharge velocity. Pag ginawa nating V din to, magdadalawa. Kaya that's why Q. Pag naman ang given na Q is already in cubic inch per minute, so you don't need to divide it by time na. It's just equal to QL over AH. Ano? So, naintindihan? If you have questions, you can just ask me personally. And also, we have to get the seepage velocity, and from the formula, it's equal to discharge velocity all over N. So, given is void ratio. That's why we substitute the formula of n in terms of void ratio. It will be equal to E over 1 plus E. So to get Vs is equal to 4.818 times 10 raised to negative 3 from the value here all over 0.34 over 1 plus 0.34. And we get the value of the seepage velocity. And that is equal to 0.0176 inch per minute. Okay, next problem. A sample of coarse-grained soil, 50 mm in diameter and 150 mm long, was tested in a constant head apparatus. So the soil sample was prepared at a void ratio of 0.5 and the total head was kept at constant at 300 mm and the amount of water collected in 4 seconds was 50 cubic centimeters. So the temperature was 22 degrees Celsius. So we have to compute the temperature correction factor and the corrected coefficient of permeability in centimeters per second and the interstitial velocity or what we call the seepage velocity. So in order for us to solve the problem, why did we encounter temperature correction factor and corrected coefficient of permeability in centimeters per second? So kasi, ang permeability, dapat siya ay in 20 degrees Celsius. So kapag ang temperature na ng ating tubig is not 20 degrees Celsius, we have to adjust. So we have to get the temperature correction factor. So the temperature correction factor is equal to 2.42 minus 0.475 ln of T or the temperature. So if we substitute it in the formula, 2.42 minus 0.475 ln of 22 degrees Celsius. That's why the temperature correction will be equal to 0.95. And then we have to get the corrected coefficient of permeability in centimeters per second. So letter B is equal to Kia. So Kia or VA, AV. V is in terms of Ki here. So we know that Q is equal to volume over time and that is equal to 50 over 4. So the volume is 50 cubic centimeters in 4 seconds. That's why we get the value of Q in cubic centimeter per second here. That will be 12.5 cubic centimeter per second. And then from this equation, Q is equal to Kia, 12.5 is equal to K, which is unknown, multiplied by 30 over 15. 30, why 30? 30 is the length of the sample, 300 mm, but we have to get it in centimeters, so that's why 300 mm is 30 in centimeters, and 15 is 150 long, so that's why 15 centimeters is 150 millimeters, multiplied by the area, so what is given is the diameter in 50 mm, so it should be 5 centimeters, and then multiply it by pi over 4 and then square it. We get the value of K, which is equal to 0.319 centimeters per second. But this is the coefficient of permeability of the soil in 22 degrees Celsius ng water. We have to get the value of the uh, coefficient of permeability in 20 degrees Celsius. And in order for us to get that, we have to multiply this K to the temperature correction factor. So the corrected K is equal to 0.319. The K we have solved already, multiplied by the temperature correction, which is 0.95, which gave us the value of the permeability at 20 degrees Celsius, which is equal to 0.303 centimeters per second. So for letter C, we have to get the interstitial velocity or the seepage velocity. So V is equal to Ki, And if we substitute it, it's equal to 0.303 multiplied by 2. Therefore, it's equal to 0.60 centimeter per second. And we know that seepage velocity is equal to V over N. If we substitute it to the formula, the discharge velocity is equal to 0.606 all over N, ang given I just the void ratio 0.5. So N in terms of E is equal to E over 1 plus E. That's why this will be 0.5 over 1.05, which will give us the value of seepage velocity that will be equal to 1.818 centimeters per second. Okay, for sample number 3. For a normally consolidated clay soil, the following values are given. So given void ratio and K in centimeters per second is 1.10 is to 0.302 times 10 raised to negative 7. And then 0.9 is to 0.15 times 10 raised to negative 7. So ibig sabihin, pag daw ang void ratio nung consolidated clay natin is 1.10, ang kanyang hydraulic conductivity is 0.302 times 10 raised to negative 7. Pag ang void ratio niya is 0.9, ang kanyang hydraulic conductivity is about 0.15 times 10 raised to negative 7. Using the formula K is equal to C sub 3 E raised to N over 1 plus E, we have to compute the value of N, the value of C sub 3, and the hydraulic conductivity of clay at a void ratio of 0.75. So the equation is equal to C multiplied by E raised to N over 1 plus E. That is the equation. How are we going to compute for N here? Ang given lang natin ay K. So, pag kinompute natin dito, halimbawa itong first pair, unknown sa atin yung C at yung N. But if we get the ratio between the two, K1 over K2, kukunin natin to, kakancel yung C na constant. So, ang may iwan na lang natin ay yung N dito. Given pareho yung K with corresponding void ratio, so we substitute it to the formula 0.302 times 10 raised to negative 7 over 0.12 times 10 raised to negative 7. I mean, that should be 0.12. All over, equals rather, quantity 1.1 raised to N over 1 plus 1.1 all over 0.9 raised to N over 1 plus 0.9. So, which gave us the value 2.517 multiplied by 1.9 over 2.1 quantity 1.1 over 0.9 raised to N, and will give us 2.782 equals 1.22 raised to N. So, N equals logarithm of 2.782 over logarithm of 1.222 equals 0.44 over 0.087, which will give us the value of N, which is equal to 5.1. So, in order for us to get C, we just have to substitute the value of kahit yung isang pair lang. So, say, for example, yung isang pair, so ang first pair natin is 0.302 and 1.1. So, we have to substitute ito formula. K is equal to C E raised to N over 1 plus E. So, 0.302 times 10 raised to negative 7 is equal to C multiplied by 1.1. We already got the value of N, which is 5.1 over 1 plus 1.1. So, we'll get 1.626 over 2.1 multiplied by constant, and will give us the value of C, which is 0.39 times 10 raised to negative 7. And then, we have to get K at a void ratio of 0.75. So, we know that K is equal to 0.39 times 10 raised to negative 7 centimeters per second multiplied by E raised to N over 1 plus E. So at void ratio of 75, we get the value of K. K is equal to 0.39 times 10 raised to negative 7, that is the constant, multiplied by the void ratio, 0.75 raised to the n, which is 5.1 over 1 plus 0.75. We get the value of the hydraulic conductivity of the soil if ang void ratio naman niya is 0.75, and that is equal to 0.514 times 10 raised to negative 8 centimeters per second. Next problem is for 4 layers of soil with different coefficients of permeability. Say we have layers 1, 2, 3, 4, and with corresponding depth and coefficient of permeability here. So we have to compute for the vertical coefficient of permeability, the interstitial velocity of water moving through the soil if it has a void ratio of 0.60 and hydraulic conductivity of 0.0018. We have to express it in centimeter per hour. So the solution, the vertical coefficient of permeability is equal to H over H1 over KV sub 1 plus H2 over K sub V sub 2 plus H sub 3 over KV sub V sub 3 plus H sub 4 over K sub V sub 4. So there are 4 layers kasi. So if we substitute the values, the total height of the soil is 4 plus 8, that will be 12, plus 12 is 24, plus 3, this will be 27. And H1 is 4 over 5, the coefficient of permeability of the first layer, plus 8 over 3, plus 12 over 2, plus 3 over 1, and we get the value of the coefficient of permeability by vertical equivalency equals 2.17 centimeters per hour. And then we have to get the interstitial velocity or the seepage velocity. And we know that V is equal to Ki. K is 2.17 from the previous calculation, multiplied by 0.0018, which is given, equals 3.91 times 10 raised to negative 3 centimeters per hour. So if we get the value of the seepage velocity, we have given void ratio. So it's equal to Vs over E over 1 plus E, or pwede naman nating itaas yung 1 plus E dito. That's why this will be equal to 3.91 times 10 raised to negative 3 multiplied by 1.60 all over 0.60. V sub S is equal to 0.0104 centimeters per hour. Lastly, our last problem for today is an unconfined aquifer penetrates 24 meters below the static water table. After 20 hours of pumping at constant rate of 87 liters per second, the water table in 2 observation wells located 36 meters and 82 meters from the well showed drawdown of 1.5 meters and 0.63 meters respectively. So we have to determine the nearest value to the coefficient of permeability of the soil in meters per day and the nearest value of transmissibility of the soil in square meters per day. So this is the illustration. So this is a 24-meter confined aquifer. So nag-penetrate daw siya 24 meters below the water table and nag-collect siya ng 87 liters per second at yung water table in 2 observation wells are respectively 82 meters and 36 meters from the well shown. 82 meters and 36 meters from the well showed drawdown of 1.5 meters and 0.63 meters here. So in order for us to get the value of K, we should get first the value of Q in cubic meter per second kasi ang given is liters per second. We have to get it in meters per day kasi so dapat naka-meter to Q. So just by dividing it to 1,000 because we know that 1,000 liters is equal to 1 cubic meter. So 87 liters per second is equal to 0.087 cubic meters per second. K is equal to Q ln of R1 over R2 multiply all over H2 squared minus H1 squared. So, ang H1 natin is 24 minus 1.5. Baliktad. Kasi yung pag-denote dito, I'm sorry. Pero, yun din yun. And then, equal to 21.5 meters. H sub 2 is equal to 24 minus 0.63 meters equals 23.37 meters. So that mas malaki yung value lagi ng H1. I mean, nung nandito kaysa dito. Kaya dito daw. So 0.087 ln of 82 over 36. So yung R1 natin dito. Over pi times 23.37 squared minus 21.5 squared. K will be equal to 2.717 times 10 raised to negative 4 meter per second. And we have to get it in meters per day. So if we have to get the value, we have to multiply it by 3,600 seconds per 1 hour multiplied by 24 hours in a day. So we get the value of K which is equal to 23.474 meters per day. And then lastly, we have to determine the transmissibility of the soil in square meters per day. T is equal to KH. So K multiplied by the thickness of the soil or height. So 23.474 times 24 meters, that will be 24, which will give us the value 563.397 square meters per day. And that would be all. So if you have questions, you can always contact me. Thank you, everyone, and hope to see you all next time.